Good morning, friends. I am Dr. Dharmendra B N. Today, we will discuss about Ramanujan's theta function, their interrelations, the three special case of theta function and their negative. The terms is phi of q, phi of minus q, xi of q, xi of minus q, f of q, f of minus q, and chi of q and chi of minus q. So, therefore, this is my fourth session on theory of partition, especially in terms of Ramanujan's theta function. Okay. So in the entry 24, Ramanujan's recorded these results. Just we have to go through that one. Just we have to observe that theorem. Ramanujan's recorded that's entry. We can call that's now we have to call this a theorem. Ramanujan's notebook part 3 entry 24 1 to 4 the chapter 16 page number 39 the recorded the interrelation between the three special case of Ramanujan's theta function and their negative and also the terms of chi of q and chi of minus q. So firstly the terms is f of minus q f of q divided by f of minus q, that is equal to xi of q divided by xi of minus q, that is equal to chi of q divided by chi of minus q, that is equal to square root of phi of q divided by phi of minus q. Just we have to observe the beauty of that Ramanujan's theta function and their relations, the terms of each positive terms are in the numerator and the denominators are negative. That's a very beautiful results. And also next one, that is a f cube of minus q is equal to phi square of minus q into xi of q, that is equal to k running from 0 to infinity minus 1 to the power of k into 2k plus 1 into q to the power of k into k plus 1 by 2. And that this summation, that is the terms of Jacobi theorem. So we already proved that the terms of Jacobi theorem, that is equal to q infinity whole cube. That means that is nothing but the terms of f of minus q whole cube. Okay. And the next one, Ramanujan recorded that chi of q is equal to f of q divided by f of minus q square, that is equal to cube root of phi of q divided by xi of minus q, that is equal to phi of q divided by f of q. It's also is equal to f of minus q square divided by xi of minus q. And the next result, that is a f cube of minus q square is equal to phi of minus q into xi square of q, and that finally that is chi of q, chi of minus q is equal to chi of minus q square. In entry 24, Ramanujan's recorded these results. We have to prove this one by one. So first we have to take in the terms of this relation, the first relation. So therefore the terms is let's consider, or we can show that f of q divided by f of minus q is equal to xi of q divided by xi of minus q is equal to chi of q divided by chi of minus q is equal to a square root of phi of q divided by phi of minus q. Can show that the terms is, so we can find out what is the value of f of q divided by f of minus q, some value, and similarly in terms of xi of q and xi divided by xi of minus q, that is also equal to some value, and similar in terms of xi of q divided by xi of minus q, in terms of that is also equal to some result, and the square root of phi of q divided by phi of minus q. Okay, we can consider the first term. The terms is what is f of q divided by f of minus q. We know that the definition of f of q, the terms of f of q is f of minus q is q infinity. F of q is equal to, when I have to replace q by minus q, that becomes f of q is equal to minus q infinity. Just we have to observe the terms is, that is minus q infinity divided by q infinity, because the statement of f of minus q is equal to q infinity, when I have to replace the value of q by minus q, that becomes f of q, that is equal to minus q infinity. Just we have to observe the terms is. Now we can expand the terms of by using q shifted factorial, both numerator and denominator terms. So that numerator terms is minus q infinity. That means the terms of here, the first term is minus, here the terms is minus q, that is minus of minus q plus. So the terms is, and the next one is the base is minus q. So therefore that even term gets the negative terms, that is 1 minus q square, 1 minus q to the power of 4, 1 minus q to the power of 6, and the odd term gets, that is a positive 1 plus q, 1 plus q cube, 1 plus q to the power of 5 up to infinite term. In the denominator term, that is, you can easily predict that all the terms are negative, that is a 1 minus q, 1 minus q square, 1 minus q cube, 1 minus q to the power of 4, 1 minus q to the power of 5 up to infinite term. Just we have to observe the terms is, you can cancel that both numerator and denominator terms, whichever is common. So that is equal to, we can observe the terms is minus q infinity is, the first term is 1 plus q, sorry, 1 plus q into 1 minus q square. The terms is both are negative, the terms is minus into minus plus, again the terms is minus is there, so therefore 1 minus q square. Next one is 1 plus q cube, because 3 negative terms, again the terms of 1 minus q to the power of 4. Similarly, it can be written as, that is a alternative sign, that even term gets negative and odd term gets positive. Denominator term is, that is 1 minus q, 1 minus q square, 1 minus q cube, like that the terms. Now we can cancel that even terms, both the numerator and denominator term here. The numerator term is, that is 1 minus q square, and the denominator term is also contains 1 minus q square. Here the terms is 1 minus q to the power of 4, and the denominator is also contains 1 minus q to the power of 4. So the next term is, that is 1 minus q to the power of 6. Here also that is 1 minus q to the power of 6. You can cancel the corresponding terms. So therefore it will get them only in terms of odd numbers. So it can be written as, that is equal to, that numerator term is 1 plus q, 1 plus q cube, 1 plus q to the power of 5 up to infinite term, and the denominator term is 1 minus q, 1 minus q cube, 1 minus q to the power of 5. So therefore we can observe the terms is 1 plus q means there is a negative sign, that is 1 minus of minus q, that is the definition of q shifted factorial. So therefore the very first term is here minus q, and the base jumps to 2, because you can observe the power of q here, q to the power of 1, here q to the power of 3. So their difference is 3 minus 1 means that is 2. So therefore the base is q square. So therefore the first term is minus q, and the base is q square, that is minus q square infinity, and the denominator term, that is in term of 1 minus q cube, that is the very first term is q, and the base is here also q square. So therefore the denominator term is q square infinity. So hence the terms is f of q divided by f of minus q is equal to minus q square infinity divided by q square infinity. So similarly, all the three values, the remaining three values must be satisfy the condition, the terms of 1 minus q, sorry, the terms is minus q square infinity divided by q square infinity. So we can call this one as equation 1. So the next one, again we can consider what is the next term is, that is xi of q divided by xi of minus q. The terms is, what is the definition of xi of q? The xi of q is q square infinity divided by q infinity. Similarly, when I have to replace q by minus q, that is xi of minus q can be written as q square infinity divided by minus q square infinity. Just we have to observe the definition of xi of q. Xi of q is q square infinity divided by q square infinity. Similarly, in terms of xi of minus q, that is q square infinity divided by minus q square infinity. Now we can cancel the terms of that numerator terms, where q square infinity, both numerator and denominator terms containing q square infinity, we can cancel the terms, and the remaining term here minus q square infinity, it will goes to numerator, and the denominator term is q square infinity. So therefore xi of q divided by xi of minus q is equal to minus q square infinity divided by q square infinity. You can call this one as equation 2. Similarly, we can take next one is, the next one is chi of q divided by chi of minus q. That is the direct definition of chi of q. We know the statement of chi of q, that it can be written as, that mathematical terms is minus q square infinity. When we have to replace q by minus q, that becomes q square infinity. It will get direct answer. The terms is xi of q divided by xi of minus q is, the statement of xi of q is, that is minus q square infinity. When I have to replace q by minus q, that is q square infinity. So, we can call this one as equation 3. And finally, we can take in that next one is square root of phi of q divided by phi of minus q. We can take the terms of square root of phi of q divided by phi of minus q, and here also we know the statement of phi of q, that is minus q square infinity into q square infinity divided by q square infinity minus q square infinity. So, when I have to replace the value of q by minus q, that becomes phi of minus q, that is q square infinity into q square infinity divided by minus q, that is not q square, that is minus q square infinity into minus q square infinity. This one is not my q square, that is some minus q only, that is not the terms of q square, the typing error. So, therefore, we can cancel the corresponding terms here. Here q square infinity, the common term is here q square infinity, and also the terms of another term is minus q square infinity. So, therefore, this one goes to numerator, this one not minus q square, is minus q square infinity, and this one is goes to numerator, and this one comes to denominator. It can be written as square root of minus q square infinity whole square divided by q square infinity whole square. A square root and square term is there, it will get cancelled. The terms becomes minus q square infinity divided by q square infinity, that is nothing but the terms of square root of phi of q divided by phi of minus q, that is equal to phi of minus q square infinity divided by q square infinity. You can call this one as equation 4. So, when after observing all the results of what is the value of f of q divided by f of minus q, xi of q divided by xi of minus q, and chi of q divided by chi of minus q, and here finally the terms of square root of phi of q divided by phi of minus q. All these values are, that is equal to minus q square infinity divided by q square infinity. So, from 1, 2, 3 and 4, we obtain the terms of f of q divided by f of minus q, that is equal to xi of q divided by xi of minus q, that is equal to chi of q divided by chi of minus q, that is equal to square root of phi of q divided by phi of minus q, that is equal to minus q square infinity divided by q square infinity. Now, let us move on to the next one. What is the next one? We have to show that f cube of minus q is equal to phi square of minus q into xi of q, that is equal to summation k running from 0 to infinity minus 1 to the power of k into 2k plus 1 into q to the power of k into k plus 1 by 2. Already told that the terms of the series that can be represented as q infinity whole cube. Okay, that is nothing but f cube of minus q. So, now I have to consider that the terms of phi square of minus q into chi of q. What is the terms of phi of minus q? Already shown that in the earlier class, that is a q infinity divided by minus q infinity. You can take in that square, and also in terms of xi of q, the definition of xi of q is q square infinity divided by q square infinity. Just what observe here, phi of minus q, the statement is q infinity divided by minus q infinity. So, we can take the square, because phi square of minus q into xi of q statement, the terms is q square infinity divided by q square infinity. Because we can observe the statement both the terms of phi of minus q and xi of q. And similarly, in terms of when I have to take in that square here, we can expand the terms, that is equal to q infinity whole square divided by minus q square q infinity whole square into q square infinity divided by q square infinity. So, we know that the statement of minus q infinity, by using that Euler identity, the famous Euler identity, minus q infinity is equal to 1 divided by q square infinity. We know this Euler statement, that is minus q square infinity is equal to 1 divided by q minus q, that base is minus q infinity. When we have to multiply minus sign, the terms is, when I have to interchange the terms of q by minus q, that becomes minus q infinity is equal to 1 divided by q square infinity. So we have to apply the terms of, what is the statement of minus q infinity whole square. Okay, by using Euler the terms, it can be written as q infinity whole square divided by using Euler identity, it can be written as q square infinity whole square into q square infinity. It's not square, the terms is, simply the terms is it is not square, so divided by q square infinity. Here we have to cancel the terms of q square, the terms of square term and this term q square infinity, it will get cancelled and it will goes to numerator, that can be written as q infinity whole square into q square infinity q square infinity. That means the terms of q square infinity q square infinity, that is nothing but the terms of q infinity. This one is odd term, the first term is odd term. One have to take a marked term is, the first term is odd term and this one is even term. So when I have to merge the terms, that becomes a q infinity, or you know this binomial q shifted factorial, that's aq infinity is equal to aq square infinity q square infinity. When I have to put a is equal to q, that becomes q infinity is equal to q square infinity into q square infinity. That means the odd term into even term, that will get the terms of q infinity. So therefore, to substitute the value of q square infinity into q square infinity, that is nothing but the terms of q infinity. So therefore, q infinity whole square into q infinity, that is nothing but q infinity whole cube. So therefore, that we know the statement of f of minus q, that is q infinity. So which implies phi square of minus q xi of q is equal to f cube of minus cube. And similarly, we know the statement of q infinity whole cube, that is nothing but that Euler, the terms of Jacobi theorem. So therefore, phi square of minus q into xi of q is equal to k running from 0 to infinity minus 1 to the power of k into 2k plus 1 into q to the power of k into k plus 1 by 2. By using Jacobi theorem, we already proved this. For this result, the terms of q infinity whole cube is equal to this series. Okay. Now, we shall move on to the next one. The terms is, you can show that chi of q is equal to f of q divided by f of minus q square, that is equal to cube root of phi of q divided by xi of minus q, that is equal to phi of q divided by f of q, that is also is equal to f of minus q square divided by xi of minus q. The ratios of theta function, whatever it may, the terms is, there is 3 special case that can be written as in terms of a chi of q. Let us consider the first one. Terms is f of q divided by f of minus q square. We know the statement of f of cube is minus q minus terms of f of minus q is equal to q infinity. When we have to replace q by minus q, that becomes f minus q infinity, that is f of q is equal to minus q infinity. Similarly, we know the value of f of minus q, that is q infinity. If it is a square term, is there f of minus q square, that is q square infinity. Just we have to observe the terms is, this is the f of minus q statement, and then the first, we can call this one as star. When I have to replace q by minus q, that becomes f of q is equal to minus q infinity. Similarly, in star, we can replace the terms of q by q square, that becomes f of minus q square is equal to q square infinity. Here also we can expand the both numerator and denominator terms by using a q shifted factorial, that is minus q. Already in the earlier slides, you can note the terms of minus q infinity is even term get, that is a negative, odd term gets a positive. So that is equal to, we can expand that q shifted factorial, that is 1 plus q, 1 plus 1 minus q square, 1 plus q cube, 1 minus q to the power of alternative sign up to infinite term divided by the terms of q square infinity is 1 minus q square, 1 minus q to the power of 4, 1 minus q to the power of 6. So, we can cancel that even term. The terms is minus 1 minus q square, 1 minus q to the power of 4, 1 minus q to the power of 6. The entire numerator terms containing both even and odd term of so here the even term get negative sign, the denominator also contain the same term, so therefore you can cancel that even term. So therefore it can be written as only in terms of odd term. So therefore that is equal to 1 plus q, 1 plus q, 1 plus q to the power of 5. So here if it is the terms containing 1 plus q means that is the by using that q shifted factorial, the statement is 1 minus of minus q. Okay, so that means the very first term of minus q, and the base is here we can observe the terms of here 3, here 5 means that base is 2. So therefore it can be written as minus q square infinity. It can be written as, and this is the statement for chi of q. So therefore f of q by f of minus q square is equal to chi of q. You can call this one as equation 5. Similarly, we can take the next one is cube root of phi of q divided by xi of minus q. Now the terms of phi of q, so we can consider cube root of phi of q divided by xi of minus q. Now the statement of phi of q is minus q square infinity, q square infinity divided by q square infinity into minus q square infinity. Similar in terms of xi of minus q, that is q square infinity divided by minus q square infinity. Just we have to observe this cube root of that phi of q is minus q square infinity, q square infinity divided by q square infinity into minus q square infinity, and that divided by that xi of q, that xi of q is q square infinity divided by minus q square infinity. So therefore we are getting cancelled that only one term, that is a q square infinity, and this term goes to numerator, that is minus q square infinity goes to numerator. So therefore it can be written as a cube root of minus q square infinity whole square, because the term here containing minus q square infinity, it will goes to numerator. So therefore that is minus q square infinity whole square divided by q square infinity into minus q square infinity, not the terms of this one is minus q, this one is q square minus q square infinity. This is not the terms of minus q, this one is minus q square. So typing here the terms is, so by using Euler theorem, again the term, so sorry, not Euler theorem, Euler case, the terms is this one can be written as Euler identity minus q square infinity, that is nothing but q square infinity into minus q square infinity. So therefore that numerator term, denominator term can be written as, that is 1 divided by, as you can observe terms of, that is equal to cube root of minus q square infinity whole square divided by the denominator term is 1 divided by minus q square infinity, because as minus q square infinity is equal to 1 divided by q square infinity into minus q square infinity. So therefore again it will goes to numerator, that becomes minus q square infinity whole cube. So that is equal to cube root of minus q square infinity whole cube. Here cube roots and cube is there, so it will get cancelled. Finally it will be appear in terms of minus q square infinity, and cube root of phi of q divided by xi of minus q is equal to chi of q. That is the statement of chi of q is minus q square infinity. You can call this one as equation 6. Next we can consider what is that, what you have to show, that phi of q divided by f of q is equal to chi of q. Again the statement of phi of q, that is equal to minus q square infinity into q square infinity divided by q square infinity into minus q square infinity. And the terms of f of minus q is q infinity. Here we want in terms of f of q. When I have to replace q by minus q, that is f of q is equal to minus q infinity. So therefore, it can be written as the terms is that is equal to, there is no terms get cancelled here. So minus q square infinity into q square infinity divided by q square infinity into minus q square infinity into minus q infinity. But the term of this one, we can observe here, it is minus q square infinity into q square infinity, that is nothing but the terms of minus q infinity. So just we have to observe here, we know that aq infinity is aq square infinity aq square infinity. When you have to replace a by q, the terms of a and both a and q by minus q, that becomes minus q infinity, that is equal to minus q square infinity. Here both the terms of a and q are minus, minus into minus plus, that is q square infinity. So therefore, the numerator terms becomes minus q infinity. So it can be written as minus q infinity divided by q square infinity into minus q square infinity into minus q infinity. Here the terms, both numerator and denominator term containing minus q infinity, it will get cancelled, that is equal to 1 divided by q square infinity into minus q square infinity. Again, by using Euler identity, it can be written as the terms is, you know the well-known theorem, the terms is minus q square infinity is equal to 1 divided by q square infinity into minus q square infinity. So therefore, overall this term can be written as minus q square infinity. Hence, phi of q divided by f of q is equal to chi of q. We can call this one as equation 7. Next, we can show that next one is f of minus q square divided by xi of minus q. Now the terms of f of minus q is q infinity, that when I have to replace q by q square, that is equal to q square infinity, because we have to observe the terms is, and also the terms of xi of minus q is q square infinity divided by minus q square infinity. Here the both numerator and denominator term containing q square infinity, it will get cancel the terms, and this one goes to numerator, that is equal to minus q square infinity. That is nothing but this statement of chi of q. Hence, f of minus q square divided by xi of minus q is equal to chi of q. So you can call this one as equation 8. From equation 5, 6, 7 and 8, we get chi of q is equal to f of q divided by f of minus q square, that is equal to cube root of phi of q divided by xi of minus q, that is equal to phi of q divided by f of q, that is equal to f of minus q square divided by xi of minus q. So it's the beauty of the Ramanujan function. So all the theta functions and the remaining terms of chi of q are there interrelated. Just we have to observe the terms. Next, the terms is, we can show that f cube of minus q square is equal to phi of minus q into xi square of q. Let us consider phi of minus q into xi square of q. So we know the value of phi of minus q is q infinity divided by minus q infinity, and xi square of q is q square infinity divided by q square infinity whole square. So therefore, the terms here, we can observe the terms. We know the value of q square q infinity, that is nothing but the terms of even and odd terms. When I have to split the terms is, that is a q square infinity into q square infinity, and also by using that Euler identity, minus q infinity can be written as 1 divided by q square infinity. So we can change the two values, that can be written as q square infinity into q square infinity divided by 1 divided by q square infinity into, that is the terms of the whole square, q square infinity whole square divided by q square infinity whole square. It will get the terms of, it will goes to numerator, this one. So the terms is, this is a q square infinity whole square, this term becomes square, so it will goes to numerator. So therefore by using Euler identity, we know the terms of q minus q infinity is equal to 1 divided by minus q square infinity, and q infinity can be written as q square infinity into q square infinity. Here we want the terms of minus q infinity. In this Euler identity, when you have to replace q by minus q, that becomes minus q infinity divided by 1 divided by q square infinity. This is that result. So it will go to numerator, that is q square infinity. So that is equal to q square infinity whole square into q square infinity into q square infinity whole square divided by q square infinity whole square. So here that both numerator and denominator terms containing q square infinity whole square, we can cancel the terms, and the remaining term is q square infinity whole cube. So therefore that is equal to q square infinity whole cube. So the terms is, that is nothing but the terms of f of minus q square whole cube, because f of minus q is q infinity. When I have to replace q by q square, that is f of minus q square is equal to q square infinity. So that is nothing but phi of minus q into z square of q is equal to f cube of minus q square. So finally that last result is, when I have to show that there is a chi of q into chi of minus q is equal to chi of minus q square. I have to consider that LHS side, there is a chi of q into chi of minus q is equal to, you know the statement of chi of q, that is minus q square infinity, and chi of minus q means that is a q square infinity. When I have to replace q by minus q, that can be written as, the terms is that chi of q is minus q square infinity, chi of minus q is, when I have to replace this result, the terms of q by minus q, that is q square infinity. So by using the terms here, even and odd, the terms is a minus b into a plus b, that is equal to a square minus b square. We are using that result, the terms it can be written as, here base is q square, and the first term here minus here first term is q, that means this one is q square q to the power of 4 infinity. You can take in the double term and with the terms of positive. You can take in the power is double and this one is a positive, that is q square q to the power of 4 infinity. That is nothing but the statement of chi of minus q square. We have to observe the statement is chi of q is minus q square infinity. When I have to replace minus q square, that becomes minus into minus, that is q to the power of 2 into q to the power of 4, sorry, q to the power of 2, q to the power of 4 is base infinity. So hence chi of q into chi of minus q is equal to chi of minus q square. Or I have to show this one by the terms of the definition. Minus q square infinity q square infinity is equal to q 1 plus q cube, that is a positive term up to infinite term, into 1 minus q q cube, that is a odd term, the terms of with negative sign. So when I have to club the terms of here, 1 a plus b here, a minus b, just we have to observe the terms of a is equal to 1 and b is equal to cube. The terms is, we can club like this, the terms is, that is a plus b into a minus b, the terms is like, we can collect the terms of with their power terms, okay, similar power. So therefore that is equal to 1 plus q into 1 minus q, that can be written as 1 minus q square. Similarly 1 plus q cube into 1 minus q cube, that is equal to 1 minus q to the power of 6. Likewise up to infinite term, it can be written as 1 minus q square, 1 minus q to the power of 6, 1 minus q to the power of 10. That is nothing but the terms of first term is here q square, and the jumping term can observe terms of here 6 and here 2. 6 minus 2, that is 4. Here also 10 minus 6. You can observe the 10 power here 6. 10 minus 6, 4. So therefore the base is 4. Q square, q to the power of 4 infinity. So the terms is minus q square infinity into q square infinity is equal to q square q to the power of 4 infinity. We know the statement of chi of q, that is minus q square infinity. We have to replace q by minus q, that is chi of minus q square is equal to q to the power of 2 q to the power of 4 infinity. So this matter end the session, and this is the reference, the Ramanujan's notebook, part 3, the Springer Verlag, New York, 1991. Thank you.